I'm Emmanuel Kim, and with my friends David Rodin and Mélanie Nguyen from Insitut Optique Graduate School, we are going to talk to you about one of our school projects this year. It's the glossiness measurement techniques for watching the degradation of Soulages masterpiece. So, who is Pierre Soulage? He's a famous French painter, and all his works are monochromatic. Here. So, we were working with Pauline Elou de la Grandière, the restorateur of Pierre Soulage's work, and during her studies, she saw that there were variations of gloss on the paintings of Pierre Soulage, and these variations of gloss were at the places where there were going to be degradations. And so, with time, glossy surfaces were becoming matte, and matte surfaces were becoming glossy. So, the goal of the project is to quantify the variation of gloss of the surfaces with optical techniques. So, in the market, there were already different methods to measure gloss. For example, we can use a commercial gloss meter, but the problem is that it's with contact, and so it will destroy the piece of art. Another solution is to use a goniospectrometer. It will analyze the way the surface reflects the light in all the directions. It's named BRDF for bidirectional reflectance distribution function. But the problem is it's not transportable in a museum. It's a very big dispositive. So our idea is to study the specular gloss. What is a specular gloss? It's a visual property of a surface. It describes the appearance of the surface with the way the light is reflected by the surface in the specular reflection. For example, here we have the formula of the specular gloss. Here we have the source in a configuration of 60 degrees of the source with the surface and the surface with the detector. It depends on the reflectivity of the reflectivity in the specular direction of the sample and the reflectivity in the specular direction of a reference. So during our work, we used the gloss scale. The gloss scale is a way to have determined gloss behaviors. For example, we have the gloss units from 0 to 100. 0 gloss unit is a perfectly matte surface, and 100 gloss unit is a perfectly glossy surface, like a specular surface, like a mirror. And so to measure the gloss, we have a new method. It's to use the image of the reflection of a source point.
So, how can we detect an optical signal? So our new method consists in analyzing the image of the reflection of a source point. So we use the following setup, which is using a source, a color chart, on a camera on a movable platform. So the light is reflecting on the color chart and detected by the camera. We use different types of surface, from the glossier to the matter. Here is a photo of the setup, which can create a point-to-point image. As you can see, we have many samples which are using different types of glossier surface. So, here are the results we obtain. We have a sharp image when this is a glossy surface, for example here, and a blurry image when it is a matte surface. for example, here. So we can quantify the gloss variation by spotting the variation of the intensity in the image. Like this, we can show that the more the surface is glossy, the more the detected profile is narrow, and the more the surface is matte, the more the profile is large. So we can easily quantify the gloss by spotting the variation. To do this, we measure the local intensity transition, which are equal to the derivative of the intensity variation. So we can see that the quicker the variation, glossier is the surface, and slower the variation is, matter is the surface. So after all, we can see that we can have a correlation between the gloss with the local variation intensity. And we have a bijective evolution as expected.
After studying about the impact of the reflected light on different glossinic, we can make an experiment with a camera, the gloss scale, and a LED fixed on a rail. Then we put on the line all the gloss from the gloss scale. On the left, it was the maddest surface, and on the right, it was the glossiest surface. Then we put the camera on a fixed position, and we put a moving LED on a rail, which will be moving with a step of 1 centimeters. Here are the photo of our setup. So we can see here all the gloss unit for the gloss surfaces from the gloss scale, our camera, the LED which is red, and the rail, and on which we have put a step of 1 centimeter. Then we take a photo at each step of 1 centimeter, and we get around 70 photos. But all these photos are in red, so we extract the red channel of each photo because it is the most interesting part of photo, especially the green and blue channel are not equal to 0. By extracting all this red channel, we can get all of these assembled photo one by one and see the evolution of the diameter of the reflected spot on all of the surface. So as David said before, on the glossiest surface, the diameter was small, and on the mattest surface, it was really big, and the diameter wasn't really visible. So on each of these photo, we choose one position for each surfaces, which correspond to the center of the spot on the ideal case. Then we keep this position and take the intensity of the pixel on all of the other photo. Thanks to this, we can get an intensity plot of each gloss unit surfaces, and we can clearly see the width of each of these spots. So thinner for the glossiest surface and big for the mattest surface. It is even more convincing when we center all of these plots on the graphics. But when we calculate this derivation, the derivation of these plots, we also have the proof that the variation of this curve is bigger for surface which is really glossy and almost inexistent for gloss unit which is low. So thanks to this small analysis, we know that a gloss surface is characterized by a small diameter of the reflected spot and a big one for the for the matte surface. But this study is not really applicable in the reality, because its limits are, in these studies we were in the ideal case by using only the center of the spot on each surfaces, but also the surfaces were big according to the spots, but it will not be the case on Soulage canvas, because each gloss unit on the canvas could not have enough surfaces according to the spot for getting a privilege of having a precise dimension for the spot diameter. But how did we manage to study on real Soulage canvas? Indeed, we get the opportunity in last February to visit the Contemporary Art Museum of Saint-Etienne and to study closer two canvas of Soulage, which was in the back storage of the museum. So here are two of my teammates, David and Emmanuel, our teacher and the partner of our project. Here, a closer image of the two canvas we have studied. The first one was painted in 1979 and the second one in 1959, which was older than the first one. So what setup did we use when we were in the museum? In front of a Soulage masterpiece, we had two smartphones. The first one was moving with always the flash open and illuminating horizontally small surfaces from the canvas, and the second smartphone, which was on a fixed position and taking many photos while the second smartphone was illuminating the canvas.
So now we will study a part of interest in the piece. So here you can see that on the picture here we have three main parts: a striated part, a matte stain, and a gloss part. So this is really interesting because it represents each part of typical Soulage paintings, which are matte, gloss, and striated. And it means that it is really representative and we can analyze it to get good information. So thanks to the technique we talked about of analyzing the pictures, the one Mélanie talked about, we are able to make a mapping of the whole picture of the gloss. So to do it, we smooth each point of the image sequence using convolution. So the smaller the convolution kernel is, the longer is the calculation time. For example, when we use a really important kernel, which is 5 by 5 pixel here, the result is obtained in 5 minutes. But if we use a convolution kernel of 1 pixel, it took 30 minutes. So the result at each point is, for this different kernel, is an average of the gloss detected, of the variation of the gloss detected by the camera finally. And we can get a gloss map with the local variation of the intensity through the whole pictures. And here is an example which is useful to enhance the different parts of the surface. So for example, here we can enhance the glossy part by threshold at 200, And we can also do the same with the math part using the maximas of the derivative to resolve that 20.
So in conclusion, our new method is really successful only at the moment only in a weak ambient light. So our method is contactless and removable. It's adapted to samples and masterpieces of Pierre Soulage that are very, very big. It can work only with a mobile phone, like we saw during our presentation, and we expect in the future to have better results with a better setup. For example, with dispositives that will move the light source, but with a big precision to have a real quantification of the way the light is reflected by the painting. Thank you for your attention.